Hello friends, welcome to our channel. I hope you are all in a very good health and studying well with your full focus. Thank you for joining me. Today we are going to discuss about critical angle and total internal reflection. This is from the chapter Refraction of Light. So let's start. When light when light travels from denser to rarer medium. When light travels from denser to rarer medium, we can see some cases. Number one, let us assume this is the boundary between two media. A light ray is coming and striking the boundary between two media. So this is our normal at the point of incidence. Let us call it ONN dashed. And let us name this ray as AO. This is our angle of incidence. So a part of this light will be reflected and the other part will be refracted. So let us assume this is the reflected part OB. Okay. So this is our reflected ray. This is our incident ray. So the other part will be refracted. So this is away from the normal. So this is our angle of refraction. Okay, angle or angle of refraction. This is our angle of reflection. So the incoming ray is divided into two parts. One part is being reflected and the second part is being refracted. Now, if we so this is our first case. Now, if we increase the angle of incidence and we keep on increasing the angle of incidence, then a time will come, okay, uh, when if we just keep on increasing the angle of incidence, we are increasing the angle of incidence, so a time will come when for a specific angle of incidence we will get a reflected ray and we shall not get any refracted ray in the second medium. The refracted ray will gradually move towards the boundary. So the refracted ray will go like this. So the refracted ray will so the refracted ray will go along the boundary between the two regions. Okay. So the angle of refraction becomes 90 degree. Okay. So that specific angle in the denser medium, that specific angle of incidence in the denser medium for which the angle of refraction becomes 90 degree is called the critical angle for that pair of medium. So this is our critical angle. Let us call it IC, critical angle. So when we keep increasing the angle of incidence at a certain point, at a certain value of angle of incidence, the refracted ray will go along the boundary. Okay, so this is our critical angle. So this is our reflected ray. This is our refracted ray. So if we define critical angle, how do you do that? The angle of incidence in the denser medium, the angle of incidence in the denser medium corresponding to which the angle of refraction in the rarer medium becomes 90 degree. The angle of incidence in the denser medium corresponding to which the angle of refraction in the rarer medium becomes 90 degree is called the critical angle for that pair of media. So this is our case 2. Now case 3. When when the angle of incidence in the when the angle of incidence in the denser medium becomes greater than critical angle, let us call it I1. I1 is greater than critical angle for that pair of media. Then there will be no refracted ray. Okay, there will be only reflected ray. So the refracted ray will merge to the reflected ray. Okay, here for these two cases we can say two parts of the incident ray. Now there is no refracted ray, there is only reflected ray. Refracted ray is merged to the reflected ray. So only reflected ray. So this phenomenon is called total internal reflection. So total internal reflection can be defined as when the angle of incidence is greater than when the angle of incidence is greater when the angle of incidence in the denser medium when the angle of incidence in the denser medium is greater than The critical angle, the ray is totally reflected back into the denser medium. There will be no refracted ray. This phenomenon is called this phenomenon is called total internal reflection. So we can say when the angle of incidence in the denser medium is greater than the critical angle for that pair of media, the ray is totally reflected back into the denser medium. There will be no refracted ray. This phenomenon is called total internal reflection. So these three cases are possible when light passes from a denser to rarer medium. So I hope this thing is clear to you. Now we can say the factors that can affect the critical angle. Okay, factors affecting critical angle. I am writing it in this place. Okay, so factors affecting the critical angle. IC means critical angle. Number one, the color of light. Color or wavelength. Color. Within bracket, I am writing wavelength. Okay. If the wavelength increases, critical angle will also increase. With the increase in wavelength, critical angle is also increases. So when the wavelength increases, critical angle IC also increases. So I am writing it as upward arrow. That means when it rises, it also rises. Okay. When the wavelength rises, critical angle also rises. Number two, temperature. If we increase the temperature, the speed of light will increase. That means the wavelength will increase, and when the wavelength increases, critical angle also increases. That means critical angle will increase with an increase of temperature. So IC will increase. Okay. When temperature increases, critical angle also increases. So these are the two factors on which critical angle depends. Okay. When the wavelength increases, critical angle also increases. When the temperature increases, the critical angle also increases. So these are the factors. Now we shall talk about the necessary condition for total internal reflection. So now we shall talk about essential conditions for total internal reflection. Number one, the light must travel from denser to rarer medium. The light must travel from denser to rarer medium. This is the first condition. Number two, the angle of incidence in the denser medium must be greater than the critical angle for that pair of media. The angle of incidence in the denser medium must be greater than the critical angle for that pair of media. I hope this is clear to you. That's all, friends, for today. Tomorrow we shall come with another video. Thank you.